Hello again! On this lesson we talk about fractions and decimals, and here we have addition with decimals. Let's get started. So the way to add them is we have to use column addition just like usual, but there is one important thing not to skip is you have to write a point under the point. You have to align them together. If there is no point in the number, you can assume that the point is here after the last whole number. So 7 point, and here to make it look normal we can write 0, 0. That is not going to change anything. If you write zeros after the point in the end, it's not changing the number. We are just making it more convenient for ourselves. And then we just do normal addition, just like usual. So we go 6 plus 9, 15, write 5, keep 1. 4 plus 8, 12, plus 1, 13, write 3, keep 1. 2 plus 3 plus 7 is 12, plus 1, 13. So we write 13 here. And we still keep the point. So the answer is 13.35. Now, in B we have a subtraction. Again, we have to align it point under the point, like this. They have to be strictly under each other. If there's no point, not a problem, we just place it here. So we write 8.00 minus 4.76. And we just do it in the same way as we would do 800 minus 476. In the same absolutely way. So we have to take one from here, one from here. We get one here. So it's 10, but actually it's 9 because we need one here, right? And so we go 10 minus 6 is 4. And we go 9 minus 7 is 2. And we go, instead of 8, it's going to be 7 because we took one out. We borrowed one thing out. Yeah, so it's actually 7. So we go 7 minus 4 is 3. So the answer is 3.24. Next one. Here we have 3.2 minus 0.487. How to do this? Again, we have to add some extra zeros. If we add zeros in the end, after the point, again, they don't change anything. You can do that if you need it. So we have 2 zeros here. We have to borrow some things. So instead of 0, we borrow 1 from here. Becomes 1. Here is 10. And then you borrow 1 from here. It becomes 9. And here is 10. Then we do 10 minus 7. 10 minus 7 is 3. 9 minus 8 is 1. 1 minus 4, we have to borrow 1 from here. So we would get 11, and here we would get 2 left. So we do 11 minus 4 is 7. And then 2 minus 0 is still 2. So the answer is 2.713. 2.713. Next one is kind of like a 2 actions at once. There is addition and then there is subtraction. So I think the way I will do it is I will do this and then I will do the rest. Okay, so this is going to be our first action. So we do 2.82 plus 3.4. We will get, so 2 just goes here. 8 plus 4 is 12. We write 2, keep 1. 2 plus 3, 5. Plus 1 is 6. So it's 6.22. And then 6.22 goes here. And we have to do 6.22 minus 4.23. Right? So we borrow stuff. 12 minus 3 is 12 minus 3 is 9. Then we have to borrow here. as well. 11 minus 2 is 9 again. 5 minus 4 is 1, so 1.99 is our final answer to D, to question D. Okay, that's addition and subtraction. Next we have multiplication. So I think I will skip some of them. I'm probably gonna do half of these questions. I will try to do more of difficult ones to explain you better how this works. So anyway, we start with A. We start with A. So the way to do multiplication is also we have to kind of make it normal, because we have all these points. It's so weird. And so what we have to do is we actually have to take the point out. So we take it one step to the right, and here again we take it one step to the right, and you see in total there's two steps, one step in the first number and one step in the second number. And now we can do the normal multiplication now that we took the points out. But keep it in mind that we took the points out. We will use that later. But for now we can just do 32 times 5. We do 32 times 5, or we can write 32 times 0.5, which is the same thing anyway. So 32 times 5 is equal to 160. I'm assuming you guys know how to multiply stuff, so I will do it more quickly, and I will try to explain what's important. And now these two steps, they have to actually come back. They have to actually come back in here. So this point, we start here and we go 1, 2. This is where the point should land. So we took it out, but now we have to take it back into this number. So answer is not 160. The answer is actually 1.6. This is a real answer. So again, 1.6. 1.6. You can write 1.60, but again, as I told you before, zeros on the right side after the point, they are just for decoration. They don't have any meaning as a digit. So just for convenience, sometimes you need them. Let's do C. Let's do C. In C we have 12.2 times 0.6. Again, the same thing. One step here, another one here. Together it's 2 steps. Right? And then we just do a normal multiplication. We just do 122 times 6, which is equal to, so we do 2 times 6 is 12. We write 2, we keep 1. 2 times 6 again is 12. Plus 1, 13. So we write 3, we keep 1. 1 times 6 is 6. Plus 1 is 7. So 732. And now again we have to take these 2 steps, and they have to make a comeback. They will make a comeback here. 1, 2. So the actual answer is 7.32. Okay, let's do something more complicated, which I think is F. F is fairly difficult question, I would say. So 1.36 times 0.42. 0.42. You can notice that there is more steps here. 1, 2, 2 steps out here. 1, 2, another 2 steps here. In total, it makes it 4 steps. You see, not 2 steps anymore, but 4 point steps, kind of. Again, we have to keep them. You have to remember this. And then we do just normal thing. We just do 136 times 42. This is what we get out of it. So 136 times 42, that's actually a lot of numbers, you know. 6 times 2, 12, keep 1. 3 times 2, 6, plus 1 is 7. 1 times 2 is 2. Yeah, now we write 0 here. And we do 6 times 4, 24, sorry, keep 2. Keep 2, then we do 3 times 4, 12, plus 2, 14, keep 1. And then we do 1 times 4 is 4, plus 1 is 5. 2, 1, 1. I'm sorry, it's getting a little bit messy. And then we get 2 plus 4 is 6 and 7. Then we get 5. And then we take the 4 steps back. We take this 4 steps back. Here. 1, 2, 3, 4. So actually the point should be here. What does it mean? It means that if there is no number before, if there's no number kind of before the point, here you see, this kind of looks empty and lonely. So we can actually add a 0 there. So it's 0.5712. 0.5712 is an answer to this question. Okay, I hope it makes sense to you, because we have more problems for this lesson. More stuff is coming. So next one is division. Here, what we have to do here, how should I explain you this? I think I know a good way. Whoops, what have I done? What have I done? One more time. Okay, so the way to do this is, again, we have to make it look normal. We want to do a normal division, not this strange decimal thing. So in A we have 8 divided by 0.5. And what we can do is we can do 0.5 times 10. We can times this by 10, right? Which would get us 8 divided by 5. Right? And this kind of looks normal already. I mean, more normal than before. So we can do actual division. But again, remember this is what we did. We times it by 10. And again, it's just like how steps work. It's just like what we did with steps. Actually, what we do, we times it by 10, right? We times this number by 10, actually. I'm just telling it to you as the steps. And we times this number by 10 as well, right? And we remember that together we times those two numbers by 100, like times 10 and then times 10 will give you 100. So we do this first to make it look normal, like this, right? And then we have to, when we get the result, we are like, wait. But to get this result, we actually times everything by 100, so this is not a right result. So to get the right result, you have to divide this by 100. This is what we are actually doing if we skip the steps analogy. This is what we actually do here. I hope it makes sense. 8 divided by 5 is equal to, we can do it as a normal division kind of. So we do 8 divided by 5. Like this, right? So 5 comes into 8 once. So we do 8 minus 5 equals 3. And 5 is not really going to fit in 3. But we are going to put a point in there. And now we can make it 30. So 30 comes into, 5 comes into 30. 6 times. So we do 30 minus 30, we write 6. 1.6 is our answer. So again, 8.8 divided by 5 is equal to 1.6. but this is not what the question is asking us. The question is asking us what is 8 divided by 0.5, and we can actually get this answer because we multiplied 0.5 by 10 actually, right? But 0.5 is a part which we divide by, so actually we have to multiply 1.6 by 10 as well to get this done, because just think about it. If this is how many fives, are in 8, there's 1.6 fives in 8, right? So that means that there should be 10 times as much of 0.5s. That's what it essentially means. But with division it gets kind of tricky, I would say. It gets really tricky with division. So 8 divided by 5 is 1.6, but 8 divided by 0.5, 8 divided by 0.5 is actually equal to 16. Another way to do this, okay, maybe this is a little bit too tricky. I will show you one more way. Maybe that's going to be better. Another way to do this is to convert them to the fraction. Let me do D for you, which is a fairly complicated example. So we can actually convert them to a fraction. So 5.8 is the same as 5 and 8 over 10, right? And divided by 0.02 is which is the same as 2 over 100, right? And we can write it as 58 over 10 divided by 2 over 100. Dividing the fraction is easy as pie. Flip the second fraction and then multiply, right? So we flip this, we will get 58 over 100 times 100, or 58 over 10, sorry, 58 over 10 times 100 over 2, right? And now we actually multiply them, so we do 58 times 100 divided by 10 times 2. We can kind of cut this a little bit. We can cut this, and we can also divide. So we would get 58 times 10 divided by 2, and we can actually divide already. We can divide 10 by 2, and we can divide 2 by 2, right? Kind of cut them again. And so we would get 58 times 5 divided by 1, which is equal to just 58 times 5, which is actually equal to 58 times 5, 250 plus 40 is 290. 58 times 5 equals 290, which is your answer. It's longer, but I think this probably makes more sense to you than another method that I just showed. So let's do it this way, right? Let's do it this way. We're just going to convert it to fractions. So 0.4 divided by 0.02 equals to, so 0.4 is the same as 4 over 10, and 0.02 is the same as 2 over 100. Again, just a quick reminder, how do we convert it to fractions? If you have a number like this, 1.23, this is units, this is tenths, this is hundreds. So in this number we have 1 unit, 2 tenths, and 1 hundredths. So we can write it as 1 and 2 tenths and 3 hundredths, 23 over 100, like this. This is how you convert it to the fraction. Okay, and back to our actual question. Division is flipping and multiplying. So 4 over 10 times 100 over 2 equals to 4 times 100 over 10 times 2. Again, we just cross the 0. If there is a pair of zeros on the top and bottom, we can cross them. And another thing we can do is we can divide 4 by 2 and we can divide 2 by 2. which is also the same as crossing them. So we get 2 times 10 divided by 1, which is the same as 20. So our answer is 20. This is how you divide decimal numbers. Basically, you just convert them to fractions first, and then you divide fractions. I think that's the best way. There is no if, no steps. You just convert them to fraction. Just one thing. Convert them to fraction and then divide the fraction. That's it. I think it's going to be easier this way. Okay, write as decimals. Okay, another topic. So there's a couple of approaches. There's different methods to solve this actually. And I will try to show you the one which I think makes the most sense, the one which is the shortest, I would say. So the shortest method is actually doing the division. Or maybe I can show you two methods. I can show you both of them, but first a division method. So we have 1 over 4, and 1 over 4 can be written as 1 divided by 4, because this is what essentially a fraction is. It's actually just a division with extra steps. Basically the same thing as division. So 1 divided by 4, which can be written as, and I know this doesn't make a lot of sense, but we do this, 1 divided by 4. So we can already place 0 in here, because 4 does not fit into 1 really. So we place 0 and we put the point, and we have 10. Alright, so 4 fits in 10 actually. 4 fits in 10 2 times, and then we have 2 as a remainder. Right, so we can get another 0 here. And 4 fits in 20 actually 5 times. So we do 20 minus 20, which is 0, and we get an answer 0.25. So 1 divided by 4 is equal to 0.25, and this is also our fraction. One more way to do this is 1 over 4. You have to think, okay, so I have this 4 here, but decimals, right? The thing about the decimals is they are essentially fractions, but with denominator being only 100 or 10 or 1000, like 1 with zeros. The denominator has to be 1 with zeros. But here in this case it's 4. So 4 doesn't really make it a decimal. But can we make it into something which is 1 with zeros? Can we make it into 10 by multiplying? Not really. So we can do times 2, it's going to be 8. We can do times 3, it's going to be 12. 10 is not there. Can we make it into 100? Actually we can. If we do 4 times 25, it would be equal to 100. 4 times 25. But again, this method, it requires some time. You have to actually think, okay, so what do we have to times it by? Is it possible? Should it be 100 or should it be 1000? But some people do prefer this method. So we times it by 25, and we have to, because it's not fair to just times one part of fraction, so we also have to times another part as well. So we get 25 over 100, which can be written as, again, 0.25. It actually becomes really easy, this action, converting fractions to decimals. It becomes really, really easy if you have an actual calculator with you. So you just write, what do we have? We have 1 over 4, right? You write 1 over 4 equals to 0.25, and there's this wonderful button in here, S to D, right? If you click it, see what happens. You get fraction, decimal, fraction, decimal, just in case. So it becomes really easy with calculator to do this stuff. Okay, let's do another one. Let's do F. In F we have 3 over 16, and 3 over 16 equals to 3 divided by 16, like this. So 3 divided by 16. 16, of course, is not going to fit into 3, so we write 0 here. Let me move this a bit. Yeah. 16, so we write 0, we get, make it 30. 16 fits in 30, actually one time. And we get 14, which is 140. 16 fits in 140, it should be 8 times. 80, 128, 128, yeah, 128 it is. 128, you see it gets a little bit complicated because if it's such a long division, it's going to get a bit complicated. 16 fits in 120. What is it? It's going to be 7 times. 7 times probably, right? 7 times we get, or what do we get? 70, 112. 112. Finally, we get something interesting. So again, we take all these zeros and we just take them down, take them down, take them down. And here we get 80. So 16 fits into 80 5 times. So finally, end of the journey. We just write 0.1875. 80 minus 80 equals to 0. Finally, we are done. Sometimes it can take a long time to convert fraction to the decimal. So again, you have your calculators with you. You can just do this, 3 over 16. In case if no one is asking you to show your working, you just do this kind of stuff. You get 0.1875. But in case if you are asked to show your working, that's what you do. Okay, what do we have? What else do we have here? We have, okay, ordering stuff. Let's do it. Let's do it. Seven over 9, 17 over 20, 3 over 4 in order of size, starting with the smallest. So it's not possible to order them when they look like this as a fractions. So what we have to do is we have to convert them to decimals in order to order fractions. We have to convert them to decimals, kind of. So let's do it. So 7 over 9 converted to a decimal is, again, okay, so I think I showed you the working. Now I can actually just do it like this. So 7 over 9 equals to 0.77777. So it's called infinite 7. We can write it like this, 7, 7, and then you just write 3 places. Or another way to write it is like this, 0.7 and then point on the top. So it means 0.7 repeating. This is what it means. 17 over 20. 17 over 20. This one's actually easy to figure out. We can just times it by 5 to make it 100. I'm not even going to use calculator for this. So it's 0.85. This is going to be 0.85. And finally, we have 3 over 4. This one's also easy. We have to times it by 25, so I don't need calculator anymore. We have to times it by 25 to get to 100. And this also we times by 25. So again, here we times by 5. Let me write a bit more working for you. So it's 85 over 100, which is equal to 0.85. And in case with 3/4, we do times 25 times 25, which is 75 over 100, which is 0.75, like this. So we have those three numbers. 7 over 9 again is equal to 0.7 repeating. 17 over 20 is equal to 0.85. 3 over 4 equals to 0.75. So the smallest number here is 3 over 4, 0.75. Again, because this is 7 repeating, so it's essentially 77777. 0.77 is larger than 0.75, right? So we write it as 3 over 4 is the first number. So this is an answer already. 3 over 4 is the smallest one. Then we have 7 over 9. And then we have 17 over 20 as our largest number in the end. Okay, that's it for decimals and fractions. Times and rates of change is another topic I prepared for this lesson. Let's take a look at it. Write down the coordinates of the points P, Q, R, and S. Okay, P, Q, R, and S. So P is okay. So this graph, you see, it's a bit tricky because x-axis and y-axis, they do not use the same scale. They use, in fact, a very different scale. You see, here we have 10, 20, but here we have 1 and minus 1 is here. Yeah. So if you would think that this is going to be something like 15 or whatever, you're not right. Again, so look at the numbers. Be careful with this. So, but here is 20. Yeah, like this one is easy to see. But here we would have to look carefully. So this is something that I would actually write here. This is 0.5. Right in the middle between negative 0.5, sorry. Negative 0.5, right in the middle between negative 1 and 0. And here, right in the middle between 0 and 1, we have 0.5 positive in this case. But P is not on 0.5. It's in fact, if we start counting from here, negative 0.5, next one is negative 0.6, because we have 10 sections here. This, maybe you also can count this, so we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like this. You have to be, I'm assuming you know how to work with scales by this time. So let's do this. So 0.5, this is going to be negative 0.6, and this is actually going to be negative 0.7. So a negative 0.7, like this. So for P, the coordinates of P are going to be, so we start actually with x coordinate. We start with x coordinate, which lies on x-axis, and that is negative 0.7, negative 0.7, and then we have a 20 as y coordinate. Oh, I'm sorry, it's too high. My face is obstructing your view, I guess. So P equals negative 0.7 and 20, like this. Next one is P. So OPQ, PQRS. I was trying to remember the alphabet. Q. So let's talk about Q now. Q is actually on negative 0.5, right? So we can start with that, negative 0.5. But when it comes to y coordinate, again, this gets a little bit tricky. So here we have 0, and here we have minus 10. But careful, count how many sections do you have between 0 and negative 10. So we have 1, 2, 3, 4, 5 sections. We have 10 numbers, but 5 sections. Well, how does that work? It turns out that actually we step by 2. So to get from 0 to negative 10 in 5 steps, we have to, each step, we have to skip 2 numbers. Not just one number, but 2 numbers actually. So it goes like this. It goes minus 2, minus 4, minus 6, minus 8, and finally we get to minus 10. So we can see that this is going to be our minus 6, or we can say negative 6. So Q has coordinates negative 0.5 and negative 6. R has coordinates, this one is pretty clear to see, right? 0.5 and negative 10. 0.5 and negative 10. And finally S has coordinates. We have to be careful here. So 0.5, 0.6, 0.7, 0.8. So this is 0.8, right? S has coordinates 0.8 and 10. Okay, this is our P, Q, R, S. Okay, copy the graph and plot T, 0.54 and U. Well, we already have a copy of the graph. I mean, we can use this copy, why not? And T is 0.54, right? So T, 0.5 is X coordinates, 4 is Y coordinates, 0.5, and here we're gonna have 4, right? Again, remember we have 2 steps. So we go 2, 4, 6, 8, 10, like this. So 4 is actually going to be here. I can kind of draw them, but it's going to be very small. I hope you guys can see everything. 6, 8, like this. So T is here, 0.5, 4. This is our T. Yeah, and U is negative 0.2 and 20. So negative 0.2, so we go negative 0.1, negative 0.2 is here, right? Negative 0.2 and 20. So 20 is here, this is our 20, this is our negative 0.2. You see the intersection is around here. So this is going to be our point U. Okay, that's coordinates. System of coordinates, ladies and gentlemen. What else do we have? Here we should be able to read the graph. I hope I captured, no, I didn't capture everything, I have to do it again. So we should be able to read this graph properly. A baby's temperature was taken every 30 minutes, starting at 5 o'clock. So first you see the start, it's a bit high. Again, we have to figure out the scale first, right? We have to understand how the scale works here. And look at this, we have 100 and we have 110. The distance between them is 10 degrees, 10 degrees of Fahrenheit system. And we have to count again how many steps do we make. We make 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 steps. This is perfect. You see, it's not a misleading part. So this scale is not very misleading. It's actually kind of a true to image thing. So this is actually going to be 111. You see, that's the easy kind of stuff. 112, 113, and you see, and so on. This is how it's going to be going. So what we have to find is at what time was the baby's temperature 100 degrees Fahrenheit. And second, we have to figure out the time thing. So here I think it would be wise to start with the middles. So we have 5:30 and 6. Exactly in the middle between them is, so the total distance between 5:30 and 6 is 30 minutes. 30 minutes, sorry. If we divide this distance in half, we would get 15 minutes on each side, right? And when we go from 5:30 to here, it should be equal to 5:30 plus 15, which would be equal to 5:45. And here in the same way, 5 plus 15 minutes is 5:15, like this. Okay. So 100 degrees Fahrenheit. It was actually, let's look for 100. So 100 is actually, I'm going to use another color. So 100 is actually it's here, right? And then we drop it down. We get to this time. What time is it exactly? So, okay, so let's try to figure out this scale. Let's take a look at it. We have 5 steps between 5:30 and 5:45. So how can we get from 5:30 to 5:45 in the 5 steps? If we try to do +1, it doesn't work, right? It's only 5 steps. So we would get to 5:35 by this way, which is not true. This is not 5:35, it's 5:45. We can go by 2, but then we're going to get to 5:40, right? And then we can go by 3. We can go by 3 steps, right? Plus 3. We're going to get 5:33, 5:36, 5:39, 5:42, and now finally we get to 5:45. So our step here is +3. This is a tricky scale. It's always tricky with time, so be careful about it. So 5:30, this is, I don't think I have enough space to draw this, so I will just draw this. This is going to be again, so 5:30, 5:33, 36, and this is going to be 5:39. This is 5:39. Let me draw this. Again, I don't have enough space to do that, to draw all of time scales. So it's 5:39 is actually our time. So in A, an answer is 5:39. I think it's 5 o'clock. I'm assuming it's in the morning. What was the baby's temperature at 5:18? Okay, so again, we have to find 5:18. We have 5:15 here, and if we go one step, if we go +3 from 5:15, we would get exactly to 5:18, which is what we need, right? And now we can go up from here. Oops, do it again. We do this, and then we draw a line here, and you see where we end up. We end up at 112 degrees Fahrenheit. What was the baby's temperature at 5:18? The answer is 112 degrees Fahrenheit. Okay, that's for question 2. And the last question is about, okay, that's actually a complicated one. I'll try to explain it properly. Okay, so number 3, how to draw. You should be, again, so this is summary, and they tell you should know how to do this and that. And here, the third thing you should know is you should know how to draw and interpret graphs with more than one component. For example, this graph shows a journey to and from the town center made by bus and by car starting at the same time. And so how many stops did the bus make on the way to the bus station? You see they give you a small example, which is in town center. Again, so here it's it's pretty important to read and analyze the text in this case, because you see they tell you this about the graph shows the journey. Because when I tried to do this question before doing this lesson, making this video, I didn't read it properly. I was like, whatever. And then I actually looked at A. I went straight to the question A, and it asks, how long did the car driver stop in the town center? I was like, what is the town center? Where did they get that from? And actually, town center, if you read carefully, if you read the description carefully, it says that this graph shows the journey to and from the town center, right? So it's here at the description of this question. So be careful. That's what I'm trying to say. Okay, how long did the car driver stop in the town center? Let's figure this out. You see, so the town center, he is making only one stop, the car driver. Again, so car journey is the solid line, right? Car journey is the solid line, and the bus journey is a broken line, right? So car journey is this thing. So he drives. You see the distance is increasing, and at some point the distance is not increasing, so this means that he stopped. The time is passing by, the distance is not changing, he stopped, he is chilling. Okay, so here the question is, how long did the car driver stop? So you see he started his stop at 10, and then he started moving again. At 11 he started going back, you see? So here this is the start of his stop, and this is the finish of his stop. And then he's moving back. So how long, again, how long? The answer is 1 hour. Yeah? So this is our A. Question A. Should I write it here? Yeah. It's question A. 1 hour. I'm gonna draw it right on the graph. So A is 1 hour. B, how long did the bus driver stop for at the bus station? Again, so here you have to read the description. How many stops did the bus make on the way to bus station? And here we get to know that bus station is essentially the same thing as a town center. It's somewhere in the town center. So we are assuming that this stop here, when the bus traveled, he started here, and when he arrives here, he also traveled 40 kilometers by car. So we assume that this is a town center, which is the same as bus station. And the question is how long, and if we try to figure this out, it should be 30 minutes here. This should be 30 minutes. Again, it's a little bit hard to say because it's a broken line, and you see it's such a small scale. I actually have a benefit of being able to zoom in, right? But if you're using an actual paper, then it's going to be hard to see. So it's hard to say for certain. So I will have to assume that it's 30 minutes, which would make sense, right? It's around half of the time between 11 and 12, right? So we are assuming that the bus has stopped for 30 minutes. So a bus stopped there at the bus station for 30 minutes. Next one, the car driver was on the way home while the bus was still on its way into town. At what time did they pass each other? Yeah, so when did they pass each other? It means they meet somewhere on the road. And for graphs, it means that those two graphs are going to intersect. You see? Intersect. At what time did they pass each other? So another one, again, it's a bit hard to read the scale. I mean, I can do it actually. But it's going to be even harder for you because in the book it's going to be so small in this book. I'm pretty certain. So okay, let's do it. Let's do it. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12. Between 11 and 12 hours, there's 12 ticks. So that's for 1 hour. 1 hour, there is 12 ticks per 1 hour, right? 12 steps. 1 hour can be written as 60 minutes. 60 minutes, so 12 ticks per 60 minutes, which would mean that it's 1 tick per 5 minutes. So this is going to be 11:05. This is going to be 11:10, 11:15, 11:20, 11:20. Sorry, why am I saying O in there? Awkward. 11:20, right? And then, so I'm assuming again that they meet here at this point, right? They meet here at this point, and if we drop down a line from this point, they drop down the line from here. It kind of lands on 11:20. Again, not exactly, it's a bit of an approximation. I could try to make it even better approximate, but I think 11:20 should be good enough approximation for this. So 11:20. Again, if you want to kind of underline it, it's approximation, you can write this. So it's 11:20. 11:20 is the time. And then finally D, between which times was the car driver's journey fastest and slowest? Fastest and slowest. So fastest, first let's look for the fastest. For fastest, the gradient has to be the biggest. Actually, the model, I mean, the absolute value of gradient has to be the largest. Absolute value of gradient. Or we can just kind of analyze this, and we can kind of assume that this is, okay, so this is our possible candidate. So of course not here, because here the car is just standing. Definitely not the fastest time. But maybe it could be here, or it could be here, or it could be here, possibly. There is 3 possible areas where this car could be going very fast. And to know for certain, we have to know what area has the biggest incline. We would say the largest incline, like this. So this area, so we go in 1 hour, here in 1 hour, this car is going to drive 40 kilometers. 40 kilometers per hour, we could say is the speed here. 40 kilometers per hour. Here in this area, you see in 1 hour, it's only 10 kilometers, so it's 10 kilometers per hour. And last one, again, in 1 hour, it's 30 kilometers. 30 kilometers. So here we have, again, this is 40 kilometers per hour. This is 10 kilometers per hour. And here, this is going to be 30 kilometers per hour, like this. I thought I would actually have to find the gradient, but no, it's a bit more simple than that. And now you can see that it was the fastest in the first, its first hour was the fastest. So from 9 to 10 o'clock. And slowest, I mean, you can kind of say that when it was not moving, that was probably the slowest time. But if they are talking slowest in terms of still moving but like really slow, that would be 10 kilometers per hour. So I think technically the right answer is 10 to 11 when it stops. So this is the slowest. And maybe, just maybe, if they mean slowest but still moving, maybe it's going to be 11 to 12. Kind of an ambiguous question. Okay, so that's it for graphs. A pretty complicated topic, so make sure you do some practice on this. And yeah, I think that's it.